Hello, everybody. Welcome back. This is lesson 3, where we'll start talking about common factors of a polynomial. Last time we talked about multiplying polynomials, so we learned that we could take two things, could be a monomial, and a binomial, multiply them together. Now, factoring is going to be that process where we take that completed polynomial and break it back up into its two factors. So think about this in terms of numbers. Let's say you have a number like 10. Right? 10 can be written as the product of two of its factors. Let's say 5 times 2. They would come together to make 10. Now, when you go to factor that number, you would basically take 10 and split it back up. That's what we're going to try to do with polynomials. There's a couple different ways we can do it. Obviously, things change since there are variables involved, but we'll see what the process is like as we go through this. So let's start by taking a look. So that first definition there, factoring, is just finding what multiplies together to get a polynomial expression. Okay, that's all it really is. So the first thing we're going to do here is we're going to factor out a greatest common factor from a polynomial by dividing each term by the greatest common factor. Then the polynomial can be written in factored form. So what does that really mean for us? So if we look at an expression here, like the first one, that polynomial is 2x squared plus 10x. So there has to be a term that's a factor of, well, both terms, really, of that polynomial. Now, if we look at the coefficients of 2 and 10, they have a common number of 5. Okay, so that's going to be part of our greatest common factor. And again, it is the largest common factor that exists between 10 and 2. Okay, so that's 5. Now I have to look at the variables. There's an x squared in the first term, but only an x to the power of 1 in the second term. That means the amount of x's that they share really is just x to the power of 1. So my greatest common factor is 5x. Now, underneath, I'm just going to write what that polynomial will look like in factored form. So we were told up above to take each term of the polynomial and divide it by that greatest common factor. And I actually just realized I made a mistake in that coefficient. It can't be 5 because my first number here is 2. So my greatest common factor should actually be 2x, not 5x like I originally had. So it should be 2x. The x is okay. Now this makes more sense in my brain. So we can take each term of that polynomial, divide it by that greatest common factor, and that's essentially what we're going to have left in our set of brackets, because if I just divide it and leave it, I'm changing the value of this. So really, factoring is like going backwards with the distributive property. Okay, so my greatest common factor is going to be on the outside. And when we divide each of those polynomial terms by the greatest common factor, that's what's going inside. Okay, we're doing all this stuff kind of backwards. So 2x squared divided by 2x. That will leave us with just x. The other way you can think about it, what do you multiply that greatest common factor by to get your original polynomial terms? If I start with 2x, I have to multiply it by x to get 2x squared. Okay, now for the other term, this is where my brain was going with the 5. If I take 10x and divide it by 2x, I have a plus 5. So imagine you actually did the distributive property. 2x multiplied with 5 would give you 10x. So in blue, there is the factored form of this polynomial, greatest common factor being 2x. Okay, let's try a little bit more complicated one underneath. Now between 18 and 27, they share a common factor of 9, and that would be the greatest common factor, 9. Next thing we'll look at, just like when we did exponents, we looked at the variables after. So we're going to look at the powers of x that exist here and figure out how much I should be able to divide out of each term. Now for the first term, the 18xy squared, I'm only actually able to divide out one power of x to the power of 1. But for the other one, I could divide out x to the power of 3. So the amount that's common to both is just x to the power 1. Oops, I lost my calculator. There we go. Now for the y's, I see a y squared in the first term, a y squared in the second term. That means that I can divide out a y squared from both, and that would be the maximum amount we could do. So my greatest common factor is 9xy squared. Now if I actually do that division and get our polynomial, our 9xy squared is the common factor. So inside is what we're going to have left over once we do this division. 18 divided by 9 gives us 2. X divided by x, there's nothing left over. Y squared divided by y squared, there's nothing left over. So this remaining is actually just 2, which makes a lot of sense. If you do the distributive property, you get 9 times 2, which is 18, and then your xy squared. So this is good. Our next term, so I have a plus sign because I had a plus sign here, and my greatest common factor has a sign that's positive. So a positive multiplied with a positive should give me another positive. So that's going to be a 3 this time. 9 times 3 is 27. I need to get to an x cubed. So x cubed divided by x, that is x squared. And then y squared divided by y squared is just 1. So there it is, my polynomial in factored form. It'll do the exact same thing. Maybe I'll leave c for you. You can try that one. It's got a negative sign, so just be careful when you go to factor things. But you can compare it to the answer key and see how you did. Let's do the same thing, where now I might have some trinomials. I know the first one is a binomial. D is also a binomial. So let's actually look at one of the trinomial examples. Let's take a look at B. Okay, so I've got a 15x squared minus 10xy minus 20xz. So we need to come up with a common factor and the greatest common factor of all three. So coefficients first. 15, 10, and 20 all have a common number between them, and it is 5. Okay, and that is the greatest because even though it looks like 10 might work, 10 is a factor of, well, 10, 20, but 10 is not a factor of 15. Okay, 10 plus 5 is 15, not 10 multiplied with 5. Okay, remember what factoring means. So 5 is the number. If I look at the x's next, I have an x squared in the first one, x in the middle term, and x on the last term. The most amount of x's I could divide out is just x to the power of 1. You're limited by the least amount. Okay, and then the y's, not all 3 terms have a y, so that can't be part of the greatest common factor, and not all 3 terms have a z, so that can't be part of the greatest common factor. So right there, your GCF is 5x. Figuring out what goes inside, 15x squared divided by 5x, this is where all those exponent rules come back into play, which is why we had to start with it. It is a little bit more challenging as a topic and a concept, but it does, as you can see, have plenty of application here. 15 divided by 3 gives you, or sorry, 15 divided by 5 gives you 3. X squared divided by x gives you that x. Middle term, negative 10 divided by 5 is a minus 2. So this is where you need to be careful with those negative signs. Okay, x divided by x is gone, just a 1. Y's will have to remain because I don't have a y in my greatest common factor. And then the last term, that will give us a negative 4. X divided by x is 1, and then z divided by 1 is just z. So there you go, that polynomial in factored form with the 5x being your greatest common factor. I keep clicking my calculator away. There we go. Okay, so I'll leave the other ones for you to attempt. C is very similar. Just make sure that you take the correct powers of A and B and the correct coefficient as a factor as you do this. So I'll fill those in for you, and you can check them in the answer key, which will be in the description box underneath. Now, here's where we start to get a little bit more in depth as we start to get into factoring. So our next lesson will be dealing with factoring some trinomials that you might not be able to take greatest common factor from. And this is where that starts to happen. So here for A, really this is a binomial because I see one term here and one term here. They are separated by that addition sign in the middle. Yes, there is a binomial in the brackets, but if you look at the bigger picture, really it's 2 terms. Really it's binomial. Okay, now in each of those terms, you're going to see that the sets of brackets are actually the same. Now really, it's just like saying 7x multiplied with that set of brackets plus 4 multiplied with that set of brackets. Really, if you're multiplying, that is technically a factor of the entire product. So that x minus 3 acts like a factor just as if it would if it was 7xy plus 4y. Okay, a common factor here would end up being the y. So if you go to factor it, you're going to have y on the outside and then a 7x plus 4 on the inside. That is exactly what we're going to do here, except it's not just y, it's this entire set of brackets. So when we go to actually do that greatest common factor, that factoring step, x minus 3 is actually the common factor. So we're going to write it just like where we would have before, right in front as that kind of coefficient place, the greatest common factor. So x minus 3 is first. And then obviously I'm going to have some stuff left over. So think about taking that whole term, 7x multiplied with x minus 3. When I divide those, the x minus 3's cancel each other out, and I'm left with a 7x. I have a plus sign because I started with 1. Now 4 multiplied with x minus 3, whole thing divided by x minus 3. Again, the x minus 3's cancel. You're left with just 4. Congratulations, you just factored that. Okay, it's the exact same process as before, really no difference, except your common factor is now a binomial. Now in our last lesson, we essentially took binomials like this, did the distributive property, and got our expanded, polynomial expression. Now we're just going backwards. Honestly, the same process. Okay, so there it is factored completely. And that means your x minus 3 is actually your GCF this time. Okay. And we could do the same thing for b, so we'll do that one as well. Now, as it looks right now, there's no common factors in the brackets yet. If you look inside each individual set of brackets, there might exist a common factor that has yet to be factored out. So let's deal with the first set of brackets, and then we'll deal with the second set independently. So between x squared and 6xy, they share a common factor of x. And that is the greatest. There's no coefficients I can deal with. Both terms don't have a y. X is the most. That means inside the brackets, you have an x plus 6y. Okay, still have my plus sign. Now the second set of brackets, we can look for a greatest common factor as well. And our goal here is to try to make the second set of brackets look identical to the first. Because if I can do that, then I'm in the example like I was for A. It's very similar. I can look at the coefficients and see that they both have a multiple. They're both multiples of 2, right? Which means 2 is a factor, and that's it, right? There's no x's in both. There's no y's in both. 2 is the greatest number that comes out of both terms. In the brackets then, that means it's an x plus 6y. And look at that. The brackets end up being the same, right? Which means my brackets are my common factor. The x and the plus 2 is what's left over. So this is going to be, oops, x plus 6y, whole thing, multiplied by x plus 2, right? Your brackets are your common factor. And your leftover kind of coefficient stuff goes together in another set of brackets. And it's factored. It's perfect. Okay, so there's how we would look at trying to break up some binomials and some polynomial expressions and try to split them into their factors. And again, factoring and factors are just two things that multiply together to give an expression. That's all factoring is. Okay, we can look at an actual application of factoring. So this person is an event planner, 3 types of party decorations, 16 banners that are $12 a piece, 20 balloons that are $2 each, and 28 rolls of streamers that cost $1 each. We want to group those supplies in a way that each group will have the same number of party supplies with no supplies left over. We're asked to determine the maximum number of groups we can make. And remember that in the groups, we want the same number of party supplies that have none left, right? So I've got 3 things. I've got 16 banners. We have 20 balloons. And we have 28 streamers. Okay, so this is what we're working with. Oops, I don't want this. Now, with this factoring piece, especially for a question like this, it's helpful to figure out what my prime factors are, the smallest numbers possible that make up each of these. And then we can see very, very easily what's common to all 3, right? Essentially, we're looking for a greatest common factor here. So for 16, you can write it as the product of a bunch of 2's, right? It's 2 to the power of 4, I believe, because 2 cubed is 8, so 2 to the power of 4 must be 16. Right, so there's 16. 2 times 2 times 2 times 2. For 20, you can do, how should we split that one up? So let's do it into 10 and 2. Yeah, so we're going to do 5 times 2 is 10 times 2 is 20. So there's my prime factors underneath. Then for 28, we'll do it into 14 and 2. So that'll be a 7 times 2 times 2. Okay, so underneath are all my prime factors. Now if I figure out what's common, I'll take a 2 from each. I'll take a second 2 from each. And that's it, right? That's pretty much all I can do. So if I rewrite this in terms of that common factor now, I have 4 multiplied with 4. For the other one, the balloons, you've got 4 multiplied with 5. And then for the last one, you've got a 4 multiplied with 7. Okay. So this really tells me that there's 4 in common to both. Okay, I want my groups, sorry, this kind of looks like a 3. That should be an equal sign. We wanted our groups to have the same amount of stuff, right? Each of my groups should contain the exact same amount of items. It's not to say that every item in each group should be the same. I don't have to have equal number of banners, balloons, and streamers, but each group should contain an equal amount of stuff. Okay, how many of each party, there's a typo there, that should be a Y. How many of each party supply will be in each group? Now the common factor of all 3 was 4. So that's really going to tell you that you should have 4 equal groups, right? Like you should have 4 groups of things. Now in each group, the purple number is kind of what tells you what's left over. So I could make 4 groups of 4 for banners, right? 16 in total, so I can split them up equally into 4 groups. For the balloons, I can split them up equally into 4 groups, but each group will contain 5 balloons. Likewise, the same logic for streamers. I can make 4 groups of streamers where I have 7 streamers in each group. So for each group then, if we were to actually write that out, each group will contain 4 balloons. Sorry, that should say banners, not balloons. I read the wrong one. 4 banners, 5 balloons, and 7 streamers. I can't write this morning. Streamers. Okay. And we're going to have 4 groups total. Okay, we're going to have 4 groups in all with this amount of stuff in the groups. We're asked also how much money will each group be worth. So up in the top, they do tell us something about money. A banner is $12 each. So let's write out what's actually in a group. So a group contains, let's do 4 banners plus 5 balloons plus 7 streamers. I'll label what all those variables means. So X was banners, that was first. Y is balloons. And Z is the streamers. Okay, and we had a dollar value to attach to each of them. So I think a banner was 12. Okay, so 4 multiplies with 12 plus 5. The balloons are $2 a piece. So there's 5 times 2 plus 7. And I believe those were $1. Yes, those were $1 each. So I can throw all of that into my calculator. I could do it mentally. Either one. 4 times 12. Okay, plus 10 plus a 7. In total, for each group of that amount of party supplies, that will cost $65. Okay, so if I have an odd amount of stuff, you can figure out how much you should have in each group by using the idea of factoring and the greatest common factor. So you get the most out of your amount of stuff with your objects in your group, okay? Now, that's more important. Like, there's an actual example. If you go grocery shopping and you have to try and buy hot dogs and buns, usually the hot dogs, they might come in packs of 8. The buns comes in packs of 12. You don't want to have 4 buns left over. So then you're going to figure out how much of each to buy. That is more of a practical application of that, and trying to figure out the equal number there. So that number really is that least common multiple, which I believe we talked about in our last unit on exponents. So again, I hope these videos do make a difference, help you out, especially during COVID. It's a weird time for everybody. So if you do like them, you know, follow me on Instagram, follow me on Twitter, let me know. Let me know if there's anything else that you would want. I'll work on the Math 30 stuff eventually, whenever that happens. So stay tuned, and this channel will change over the next year here, especially since I get to work from home. I get a lot of stuff done here that I would not have normally been able to do, which is really, really nice. So again, stay tuned for the next one when we talk about factoring all of those trinomials. So everybody take care, and we'll see you next time.